What's up guys, welcome back for another video. So in this video, I'm going to show you how to use transformations of functions to graph of specific functions. So we'll talk about two types of transformations. We'll do vertical transformation and horizontal transformation. So let's take a look at what they are. So let's take a look at what is a vertical shift. So vertical shift, you can also think of it as vertical translation. So for example, looking at the first graph, we have our basic function, which is this function right here. This is this function, which we're calling it f of x is equal to x squared. That's the basic function of the quadratic x squared. Now, if you observe, the pink graph has been shifted up 4 units. So that's a vertical shift. So the equation for the pink is going to be f of x is equal to x squared plus 4, because the graph being shifted 4 units up. If you grab a point that's on the graph of x squared, say 0, 0, and then move 4 units up, you'll end up at 0, 4. So that's what we call a vertical shift, upward 4 units. Now let's take a look at the second image, where we again start with our basic function, the green, which is f of x equals x squared. Now to obtain the blue graph, we're going to shift the original graph downward 3 units. So the equation for the blue would be f of x is equal to x squared minus 3. So what did we do? We took the point 0, 0, and we shifted down 3 units. So we're now at 0, negative 3. So that's a transformation vertical that's being pushed down 3 units. Hence, we can generalize this and say that if we have f of x plus some constant c, this means you're going to move up c units. And then if you have f of x minus some constant c, you're going to move down by c units. So that's what we call a vertical shift. So we are changing our y coordinates for each of these basic graph by some c units. Now let's take a look at what is a horizontal shift. So horizontal shift works as follows. So let's take a look at the first image. Again, we're starting with our basic function, which is the green, that is x squared. And what are we doing to it? Well, we're moving it to the right by 4. So again, if you focus on the point 0, 0, now move it 4 units to the right, you're sitting at the point 4, 0. So what happened is your x coordinates being shifted 4 units to the right. So the equation for the pink is going to be f of x is equal to x minus 4 squared. Because now you're changing the x coordinate, so it's going to be inside the parentheses, you would add or subtract. In this case, we subtract because we're moving to the right 4 units. Now take a look at the second image, where we have again the same basic function, the green, f of x equals x squared. Now to obtain the red graph, we're actually moving the graph 2 units to the left. So that's why we have the point negative 2, 0 on the new graph. So therefore the equation for the red is going to be f of x equals x plus 2 squared, which means you're moving the original graph x squared 2 units to the left. So you're adding 2 to it. So hopefully these make sense. Now let's write down the rule in general. So for horizontal shift, we are going to write down 2 rules. If we have f of x minus some c, where you're subtracting from your input values, which is x, this means you're going to move the graph right by c units. And if you have f of x plus c, So again, now we're adding to the input value x, we're going to move left c units, where c is any real number. So these are the two rules we have for horizontal shift. Now putting both of these ideas together, let's do an example. So take a look at this problem. We want to graph this function by using transformations. So first what I'm going to do is rewrite the function. So we're going to rewrite g of x. We have the square root of x minus 3 plus 1. I always like to have the constant plus 1 or any constant, say c, move it at the end of the equation. That way you can identify your shifts clearly. So first we're going to identify what is our parent function or the basic function. So the basic function looks like we're going to start with a square root of x, and then we're going to apply transformation to that. So first we're going to do x minus 3, which means you take the function and you subtract 3 from the input, which looks like a horizontal shift. So this means we're going to shift right 3 units. And then from there, we're going to do plus 1. So that looks like you take the original function f of x and you add 1 to it. So what that means is you're going to shift the function upward 1 unit, because that's a vertical shift. And that will give us our final sketch. So let's graph this. So we start with our basic function, which is a square root of x. So let's draw our xy plane. So here is the xy plane. A square root of x, if you recall, a looks something like this. That is the function, a square root of x. And then from here, we're going to apply transformations. So first, we're going to move right 3 units. So always grab one point that's on the graph. So I pick 0, 0, that's easier. And then go 3 units to the right. So you have now this graph. So this is the graph, a square root of x minus 3. And then from here, we're going to go up 1 unit. So that will be our final sketch. So we have 3, 1, and again, make the same shape. So that is our function g of x, which is equal to a square root of x minus 3 plus 1. And this point is 3, 1. So there you have it. We are able to graph this function by using transformations. So I hope horizontal and vertical transformation makes sense to you. So that's it for this video. I hope you enjoyed.